All right, welcome to today's class. Today's class is set part one. Set part one. And we are saying here that a set is a collection of well defined objects or things, which simply means that for the collection to be called a set, it must be well defined. This word well defined is very important. If it is not there in your definition, then that is not correct. So, a set is a collection, a grouping of well defined objects or things. The next item we want to define there is universal set. The universal set is the background set upon which elements of all other sets can be derived from. Elements of all other sets are gotten from the universal set. And this is the symbol for the universal set. Either you write it like this or you express it like this. So that's universal set, the background set upon which elements of all other sets can be derived from. The next term we want to define is elements of a set. Elements of a set, this refers to the members of a set and it is denoted as this. Members of a set and it is denoted as this. For example, if you have x is equal to, let's say, 2, 3, 5, 6. All these numbers that are here, 2, 3, 5, 6, are called elements of the set X. In other words, they are members of the set X. So that is what we call elements of a set. They are members of this set X. They belong to this set X. So if an expression like this is given and you are asked to read, how can you read this expression? This simply means 2 is an element of the set X. You can also read it like this: 2 is a member of the set X. You can also read it like this: 2 belongs to the set X. So those are the three different ways you can read this expression. 2 is an element of the set X. All right, let's check another thing. Complement set. A set of all the elements that are in the universal set but not in that particular set is called a complement set. A set of all the elements that are in the universal set but not in that particular set. And it is denoted like this: A raised to power small c, that's A complement. Or you can write it like this. What that simply means is that if the set is A, universal set minus A is A complement, because we are saying A complement simply refers to all the elements that are in the universal set but not in that particular set. It can also be written like this. For example, if the universal set is a set of numbers from 1 to 10, set of numbers from 1 to 10. Okay, let me say from 1 to 8, set of numbers from 1 to 8. And then A is a set of numbers, let's say 2, 7, 5, 6, and then 1. Now, your question will be, why are the numbers not in order? Why did I not arrange it in order of magnitude? The reason is this: when you are listing elements of a set, the order is irrelevant. The order is not important. What that simply means that it is not a must that you should write 1 before 2. You can arrange it like this. It is still the same thing. So the order of listing elements of a set are not important. All right. Now, if you want to find a complement, from the definition of complement of a set, it simply means all the elements that are in the universal set but not in that particular set. So what you do is check out the elements that are in the universal set and not in this set. If you check, you see that 3 is in the universal set but it is not in the set A. If you also check, you see that 4 is in the universal set but not in the set A. Which other ones? 8 is in the universal set, but not, and that's all. And that's all. That's all. 3, 4, and 8. Those are the elements that are in the universal set and not in the set A. And not in the set A. So A complement will be this. All the elements that are in the universal set are not in the set A. That is what complement of a set is all about. All right, let's look at the next term, union set. The next term we have is union set. And we are saying that union set is a collection of all the elements that are in two or more sets without repetition. Collection of all the elements that are in two or more sets without repetition. And it is denoted like this: A union B. That's how to read it. A union B. Now, for example, if you have a set A is equal to 2, 3, 5, 10. And then B is equal to 1, 2, 3, 11, 12. And you want to find A union B. A union B simply means a set of all the elements that are in A and in B without repetition. That means 1 is part of it, 2 is part of it, but you will not write these two times. We have 2 in A, we have 2 in B. You will not write it 2 times. That's the meaning of without repetition. And then 3, 5, 10, 11, 12. 12. That will be the answer. A set of all the elements that are in the two of them without repetition. You do not repeat an element. That's what union of two or more sets is all about. And you notice something. When listing the elements of a set, each element is separated with comma. Each element is separated with comma. And then we put the elements in curly bracket. So this is the only bracket that we use in naming a set. So for example, if you see an expression like this is not a set because you are not using curly bracket. So the only bracket that we use for set is curly bracket. Any other bracket, then it is no more a set. And of course, each element must be separated with comma. All right, so that is that for union of set. Let's look at another definition. Intersection. Now, collection of all the elements that two or more sets have in common is called the intersection of the two sets. And it is denoted like this: A intersection B, a set of all the elements that the two sets have in common. For example, if we still maintain this, assuming A is this, B is this, and we want to find A intersection B, a intersection B is simply a set of all the elements that are in A and also in B. So if you look at it, we have 2 in A, we have 2 in B. That will be part of the element. We also have 3 in A, 3 in B. That will be another element. We don't have any other one. So A intersection B will now be 2, 3. Set of all the elements that they have in common. Set of all the elements that they have in common. So that's what intersection is all about. We have another thing, a null or empty set. A null set is a set without an element. A set without an element. For example, and it is denoted like this or this. Now take note, this is not a null set. This is not a null set. The reason is that 0 is an element. This set has an element which is 0. So it therefore means that it is not a null set. Okay, with that, we have come to the end of today's class, set part 1. Do well to subscribe, like and share. Watch out for the next video on set part 2 where we will define more terms before solving some past questions on WAEC, NECO, JAM, and even Cambridge past questions. So bye for now. Thank you for watching.